Welcome. In this lesson, we're going to be talking about gradient, and then you're going to complete exercise 9F. Let's begin by reading through our learning intentions here. They say the following, our learning intentions. To understand that gradient is a number measuring the slope of a line, to understand that gradient can be positive, negative, zero, or undefined, and to be able to find gradient of a straight line, to be able to find the gradient of a straight line. Now, this word gradient is probably new to you. You may have never heard of it before, so we have to ask ourselves, what is gradient? Here is a definition. Gradient is the measure of how steep a slope is. Gradient is the measure of how steep a slope is. So here, the greater the gradient, the steeper the slope is. So if we look here, I want you to pretend that you're walking up this line right here. You're trying to walk up this line. Is that going to be easy or is it going to be hard? It's going to be very hard because it's got a steep, it's very steep. Let me write very steep. It's very steep. And what that means is that it has a large or a high gradient. So the gradient is really just another word for steepness. How steep is something? If it has a large steepness, then it's got a large gradient. If, on the other hand, the smaller the gradient, the shallower the slope is. So again, picture yourself trying to walk up this slope here. It'd be far easier, wouldn't it? Because it's less steep. Or you could say it's got a shallow steepness. So what that means is it's got a small gradient. So have you got a large gradient or have you got a small gradient? It depends on how steep the line is. So a less steep line has a small gradient. A very steep line has a large gradient. And that's all gradient is. So I want you to think of gradient in terms of the steepness of a line. Steepness of a line. So now if we come here and we compare the gradient of the following lines, and I asked you just to give me do you think this is a big gradient or a small gradient? Do you think that this is a big gradient or a small gradient? The line. So the gradient of the line, do you think it's got a big gradient or a small gradient? Well, the gradient of the line, the gradient of the line would be small. It would be a small gradient because it's not going up very, very much. This one, on the other hand, the gradient of this line would be large. Gradient of the line would be large. Why is it large? Because it's very steep. It's very steep. So remember, your gradient is just a measure of steepness. Is it steep? Is it very steep? Then it's going to have a large gradient. If it's not very steep, the line's going to have a small gradient. So the gradient of the line would be large. The gradient of the line would be small. Okay, let's now talk about positive and negative gradient. I'm going to begin by reading these definitions. A gradient is positive if y increases as x increases. The rise is to be considered positive. Positive gradient. Now that's a bit of a mouthful, isn't it? I just want you to ignore that for the time being. We'll come back to it, but let's look at our definition for the negative gradient. A gradient is negative if y decreases as x increases. The rise is to be considered negative. Again, a real big mouthful there. And I don't want you to get lost in these definitions because there's a very simple idea that we're getting at here. I want you to look at this graph and I want you to look at it from the left to the right. From left to right, is it going up or down? Well, from left to right, it's going up. And because it's going up, we say it's got a positive gradient. Let's look over here. Looking at it from left to right, is this thing going up or down? It's going down. So we say it has a negative gradient. And that's all these definitions here are saying. But they say it in mathematical ways, which sometimes can be confusing. But all you need to know is that if you're looking at something from left to right, if it's going up, it has a positive gradient. If you're looking at something from left to right and it's going down, it has a negative gradient. If we look at these definitions a bit more, and you want to make some sense out of them, this is saying if the y increases as x increases. So if we take a look at that for a second. So let's say my x is increasing from here, from -1 to 1. Well, from -1, would you agree that the y value it looks small? But from 1 to here, so as my x increases to this spot right here, my y value is bigger. So the y value increased as my x value increased. Again, if that really doesn't make any sense, don't stress too much. All you have to know is from left to right, it's going up, it's positive. If we were to try to make sense out of this mathematical description here, as x increases, so again, from going from -1 to 1, my x went from here, and then it went to here, it went down. So as my x increases, my y decreased. But again, if you want to say, you know what, I don't understand what this is saying, don't stress too much. All you need to remember is that from left to right, is it going down, or left to right, is it going up? So now let's determine now, state whether the following has a positive or negative gradient. State whether the following has a positive or negative gradient. So you're going to be looking at them from left to right and asking yourself, is it going up or down? It's going up. So it's going to have a positive gradient. Positive gradient. You should pause the video and see if you can do the rest yourself. Looking at it from left to right, it's going down. So it's going to have a negative gradient. Again, make sure you're pausing before you're watching me. Here, it's left to right. It's going up. It's going up. So it's going to have a positive gradient. And again, looking at it from left to right, it's definitely going down. Quite steeply down. It's going down. So it's going to have a negative gradient. So positive, negative, negative there. Hopefully you were able to get all those correct. Remember, you're looking at it from left to right, determining whether it's going up or down. All right, we keep on going here. The next thing we need to do is we actually need to provide a measure of gradient. So we actually need to measure it, measure or quantify the gradient. We need a number. So up till now, we've been talking about, is the gradient big? Is it small? Is it positive or negative? But that really isn't good enough. We need to actually provide a number to represent the gradients. And this is where we come to this very important definition, a formula that you need to burn into your brain. Gradient is equal to the rise over run. Gradient is equal to the rise over run. Now, let's look at this line here. So we've got this line here. It's going up. The vertical distance is my rise. The horizontal distance is my run. So the vertical distance is my rise. The horizontal distance is my run. And every line, so this line, every line is going to have the horizontal distance that it travels and the vertical distance that it travels. And all you're going to do to figure out what the gradient is you're going to take the rise and divide it by the run. So here my rise is 3 and my run is 1. So 3 over 1 is 3. So that means my gradient is equal to 3 for this first one. So we can put that in the red box. That is my gradient for the first one. So we're using this rule, rise over run. And you're going to hear me say that again and again and again and again. Now, if we look at the next example here, and let's just take a guess before we look at it. It looks shallower than this one, right? So we would expect our number to be smaller than 3. That's what we should expect. And in fact, that is going to be the case. We remind ourselves of what the formula for gradient is. It is my rise over my run. Here, my rise, which is the vertical distance, is 2. My run is greater. Do you see how far my run is? My run is 8. And you can probably already take notice of the fact of, when you have a shallower line, the run is going to be greater than the rise. And you can kind of just take note of those things as you go. And that's why this makes sense. So the rise is 2, the run is 8. 2 on 8, you have to write that as 1 on 4. And you see how 1 on 4 is smaller than 1 on 3? And that makes sense because the gradient of the line was shallower. The gradient is smaller because the line is less steep. Okay, there's also another important thing we need to take note here. Did you realize that both of these were positive gradients? Positive gradients. They were both positive. So they don't have a negative in front of them. And that makes sense because as you're moving from left to right here, you're going up. As you're moving from left to right here, you're going up. So it made sense that our answers were also positive. Let's now move on to the next one. You should immediately notice that my answer here should be negative because moving from left to right, it's going down. All right, so that's the first thing. But let's approach it as normal. Okay, so my gradient here is going to be my rise over my run. Now, this is a 2. I'm going to say that my rise here is going down by 2. And then it's got a run of 12. So I'm saying that my rise here is -2 because it's going down. It's going down. It's not just 2, it's -2, I'm going to say. My rise is -2. Rise is -2, my run is 12. Because it's going down. Rise is -2. Run is 12. So that means I'm going to get -1 on 6. Do you see how that makes sense? The reason why we said the rise was going down? Because we knew that my answer had to be negative. Because from left to right, it's going down. So we knew it had to have a negative gradient. Negative gradient. Whoa. So that's why we said that. And it's very important that you realize that when you've got a negative gradient, you say that the rise is going down. All right, let's keep on going. What about this one? My gradient is my rise over run. My rise this time is going down by 9. My run is 3. -9 on 3 is -3. Again, you need to take notice of the fact that it is negative. And then, that should be red. And it makes sense that it's negative because we're saying that the rise is negative. But it's really important that you're looking at these things and you're going, all right, from left to right, it's going down. That's why it's negative. So I really want to draw your attention to that because lots of people make mistakes with that. They just go, it's 9 on 3 or it's 12 on 2, 2 on 12. They don't stop and think about whether it's positive or negative, but you're going to be different. You're going to think about whether it's positive or negative. Also, take note of the fact that this is a steeper line than this line right here. So that's why our negative is larger. So it's a smaller number because that's how negatives work. They're weird, but you can think of it as a more negative number than this one. Okay, let's keep on moving. We now need to take this key idea of rise over run and see if we can apply it to finding the gradient of a line when we are on a Cartesian plane. So we're just building up slowly here. We've got our gradient, and we know that my gradient is equal to my rise over run. Well, my rise when I'm on a Cartesian plane is just going to be the change in the y value, and my run is just going to be the change in the x value. But then we're like, well, where exactly do you start from? Like rise and run from which points? And it actually doesn't really matter. So choose, well, that's not how you spell choose. Choose 2 points on the line. Just make sure they're whole numbers. Like for instance, you wouldn't want to choose this point right here because I have no idea what that point is. But this point here, this is the point 2, 5. And let me just write that up here, 2, 5. And then let's choose another point. Let's choose this point here. And I'm choosing that point because it's got nice round coordinates. They're integer coordinates, which are nice. What I'm now going to do is find the rise and run of this. And I might just write down this a bit further down. So I'm going to find the gradient of this by considering my rise over my run. Dot, 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 1, 2. So this has a rise of 2. This has a run. There's just one spot there. So it's a run of 1. This had a rise of 2. So I'm going to put 2 here, 1 there. Also take note of this. 5, because this is change in y. It's from 5 to 3. 5 minus 3. Now we're not going to go into this too much, but you can subtract 5 minus 3 and you can get that 2 from it. So too, for your x value, you could say, well, I'm going from 2 to 1. 2 minus 1. And that's going to be equal to 1. And that's another way of thinking about it as being 2 over 1. And that's what it means when it says change in x, change in y. So the run is your change in x, which is 1. And then your rise is your change in y. So you're subtracting your y values from each other to get that 2. Don't get too stressed out about doing it formally like this. In the problem solving type questions in the exercise, they will be instances where they get you to do this when you're subtracting it away to find the rise and run. But in the other parts of the book, the exercise, they just expect you to be able to look at the graph and recognize, hey, there's 1, 2 spaces here, there is 1 space there. Now, I also want to talk about the fact that it doesn't matter the points you choose. They're always going to have the same gradient. So let's actually find the gradient again, but choose another point. Let's choose this point down here, and we'll come up to this point there. So this time, my rise and run are going to be a bit different. So my rise this time will be 1, 2, 3, 4. And my run this time will be 1, 2. So my rise and run is, my rise was 4, my run was 2. Do you notice how it's still 2? It doesn't matter the points we choose. We got the same gradient of the line. So that's really important. Don't get too thinking you have to choose certain points on the line. You just choose 2 random points on the line. You find the rise and run of them, and you're going to be absolutely fine. And also take note that it's the rise over run is the change of y of the change of x. So again, I don't want to go on this point too much, but if you wanted to, what you could do here, now this one's a bit cool. You could say, I'm going to take my, y values. So I'm going to take 3 and -1, and I'm going to subtract them from each other. I'm going to take 3, subtract -1, and then for my x values, I would take 1, and then subtract away -1 from that. 3 minus -1, that's 3 plus 1 is 4. 1 minus -1 is 2. 4 and 2 is 2. 4 and 2 is equal to 2. Again, don't get too stressed about that. So if you're looking at that and you're like, what? That is in the problem solving type questions, realizing that you can find the change in x, change in y. But I'm happy for you to come speak to me and we can talk about that kind of stuff. The main important thing is that you can do questions like this. So here is the question. It's asking you to find the gradient of the graph. You might want to pause the video and see if you can do this one yourself. All right, so how did you go? I'm going to take this point, 0, 0, and this point here, and figure out what the rise and run is going to be. So my gradient is the rise over the run. My rise here is 1, 2, 3, and my run here is 1, 2. So my answer is going to be 3 on 2. I could write it as 1.5. Nice and easy. That's all you're doing there. Nothing too crazy. Let's move on to the next one. Again, pause the video and see if you can do it for yourself. I'm finding the gradient. I know that my gradient is equal to the rise over run. I'm going to take this point and this point. Now, my rise here, I'm going to say it's -4 because it's going down -4. And then it's going across a run of 4. So this is where negatives come into play, because you have to look, you always have to look, going left to right, is this thing positive or negative? Well, it's clearly going to be negative because it's going down. So you're going to say your rise is -4, and then your run is 4, which means your answer is going to be -1. So if you looked up at the first one here, from left to right, it was positive, it was going up. So you always have to keep your eye out for that. Don't forget about whether it's positive or negative. That's a really important thing. Okay, let's keep on going here. So we got those answers right there. So 3 on 2 or 1.5 and -1. Okay, only one more page and then we're all done, everyone. And this is a nice easy page. We have to talk about the difference between zero gradient and undefined gradients. A gradient of a horizontal line is 0. So if you have a horizontal line, the gradient is 0. So this line right here, the gradient of it would be 0. And let's think about why this is the case. My gradient is equal to my rise over my run. Well, what's my rise here? What is the rise of this graph? Well, it doesn't rise at all. It's got a rise of 0. And then you could say that the run is, well, I could just take 2 random points. I could say from 0 to 2. So that means 0 to 2. What's 0 divided by 2? It's just 0. So the gradient of any horizontal line is going to be equal to 0. Now, this one's a bit more interesting. What is the gradient of a vertical line? This one might throw you for a loop a bit, but again, it's just a memorizing thing. The gradient of a vertical line is undefined. Whoa, it's undefined. Let's talk about this. So again, let's write down the formula for gradient. It's rise over run. My rise this time is from 0 to 4. From 0 to 4. So I'm going to say, I've just chosen 2 random points there. Just from here to here, it's 4. What's my run? Well, I'm not running anywhere here. There is no horizontal distance here. So I'd say it's 4 on 0. Now, grab your calculator and put in 4 divided by 0 and see what your calculator says. If I go 4 divided by 0, it goes divide by 0 error. You can't do this. You can't divide by 0. You can go 0 divided by, whoops, if I clear it. In the first one, we can go 0 divided by 2. That's 0. But if you go 4 divided by 0, your calculator breaks. It's just not possible to do that. And that's a key thing about maths. You can never divide by 0. This is undefined. It's undefined. So the gradient of a vertical line is always undefined because you can't divide by 0. And that's really important takeaways there. So now when we come to this question here, you should be able to pause the video and answer whether the following have a 0 or undefined gradient. All you're really looking at is seeing, well, and I'll go through them now, so hopefully you're back with me. What you're going to do now is, well, this is vertical. And I know that a vertical line has an undefined gradient. And that's all you have to do here. So pause the video, make sure you are giving this a go yourself. This one's horizontal. And I know that a horizontal line has a 0 gradient. This one's vertical, so it's undefined. It's an undefined gradient. And then this one is horizontal, so it's going to have a 0 gradient. Oops, let me write it down there. All right, we've only got one more question to go. This one's a bit of a long one. Okay, the last thing we need to do here is we need to talk about, and this is actually, we're not learning anything new here, this is just solidifying everything. Decide if the lines A, B, and C or D on this graph are positive, negative, 0, or undefined. Pause the video and give this a go yourself. So let's now have a look. My A, so my A line here, what you need to consider is from left to right, what's happening? Well, it's going down left to right. So that means it's going to have a negative gradient. Let's look at B now. B is a vertical line. It is vertical. And I know that vertical lines have an undefined gradient. Undefined gradient. It's because it is vertical. What about C? My C is the red line here. Remember, you have to read it from left to right. It's going up. So it's going to have a positive gradient. And then last, but certainly not least, is D, which is horizontal, which means it has a 0 gradient. And that is everything for gradients. Hopefully you feel confident with this idea. What I now need you to do is begin your exercise, which is, if we scroll all the way to the top, look how many notes we went through just then. Madness. It is 9F. Good luck, and make sure you ask me any questions if you get stuck. Bye-bye.